Hi, and welcome back to this, episode 12 of my ongoing saga of overhauling this old Sieg 7x12 mini-lathe. I've already finished the bed. The headstock's pretty much all scraped to the bed. Everything's nice and squared up. The saddle's been scraped to the bed. The cross-slide's been done. So what's next? Next I need gib strips to lock the saddle down underneath the bed. Here you can see the manufacturer's half-ass solution. They're just these very roughly chopped out strips which used set screws to push the strip away and then another set of screws to pull the strip in. And using those counter forces you could set your clearance. Basically a horrible solution because of course they caused a lot of tilting and binding, and I sort of improved on the solution by removing the set screws, measuring and shimming those strips out. So that's the way I was operating the lathe in the past. But since I've put this much work into the machine already, I figure I might as well go to some decent solution here and try and make tapered gibs to take out all the play and make them nicely adjustable. So what I don't know is what angle you need for a tapered gib, whether it's 1 degree, 2 degrees, 3 degrees. So I better go on the internet and have a look. So it says here we should be looking at about a 1/4 inch per foot of taper. So that's a 1 in 48 taper, metric machines 1 in 50. Based on the way I've been doing this job so far, what would you guys consider this? An imperial machine or a metric machine? I've had some complaints on the comments section about completely matching imperial and metric so far, so maybe I should go for a 1 in 49 just to split the difference. To make the gib blocks, I've got this offcut of 20 by 30 millimeter mystery steel. It's long enough to get both of the gib blocks out of. And for the gibs themselves, the star of our last show, Renault brake disc, will be returning for another cameo where I'll lop another slice off it. And if you want to make a real mess of your workshop, but also trail sort of black footprints throughout the whole place, grind some cast iron. Makes a great job. gib blocks roughed out now and the holes drilled, etc. But what I need to do is cut the taper. I was first thinking of doing it using a angle plate, but then I thought about it and realized, wait a minute, I've got a CNC mill. This is a 1:50 taper, so basically this is 100 millimeters long, so I just need to go 2 millimeters further over the length, which is pretty easy math. So I'll just write a quick toolpath. First, to hog out the this area down to, I think, 6 millimeters deep, and then I'll do a couple of passes which take out which cut in that angle. This end mill is starting to get pretty worn, as you can see. If I use my little magnifying lens on the camera, on the phone, you can see that the edges are really starting to look quite chewed up, and I started noticing that in the surface finish. So what I'll do is I'll switch this end mill out for a fresh one. Where are we? There. This is brand new, because I really don't want to risk anything on this this angled cut. This end mill then goes in my stuff to be sharpened ice cream container, which lives next to the Clarkson. Whenever I get enough things together, or whenever I need one of those tools, then I do a bit of a sharpening session. Under here is where the rack normally mounts to drive the saddle. But because this has been CNC'd, the rack's no longer needed. In fact, I'm not sure what I've done with it. Doesn't matter. Using the rack's mounting holes, I now mount a chip guard to keep the swarf off the lead screw. Because of this radius through here, I'm also going to need to put a radius on the bottom of the gib block in this area. There are quite a few bits which aren't going to go back onto this machine, so I guess we're going to need a scrap bin. We already have quite a few candidates for the new scrap bin, such as the headstock bearings, the original cross slide, the gibs from the saddle, or from the cross slide and from the saddle, the old broken plastic gears. The last job on these gib blocks is to drill the gib adjustment screw holes, not drill, to tap them, sorry. So those are the gib blocks finished. If you're interested in the design, it's pretty much a copy of a design I found on the internet under warhammer.edu, I think. I'll put a link in the description below. The original was Imperial. I've made these metrics with a 1 to 50 taper. Well, now that the gib blocks are finished, I need to start digging a gib strip, or 2 gib strips, out of this piece of brake disc. I've now roughed in the blocks and the gibs themselves. In the instructions that I linked below from Rick Kruger, he recommends making them over length because you don't really know where they're going to end up and you can trim them to length after. So these, they fit quite nicely. So I've got about 15 millimeters of adjustment here, and this will all get trimmed off once they're installed. Another thing I did notice is when machining gibs, if you make them in pairs like this, obviously this here I need a pair, but if you were making them for a cross slide, I would still recommend making them in pairs because it's a lot easier to hold them in the vise by just clamping them together if you need to trim the thickness. Now if you're like me, you're probably hoping that this stuff's all perfect and can just be installed and used straight away. Unfortunately, it's probably not. Generally anything I make is far from perfect, so let's have a look. We'll blue it up and see whether we can use it or whether we need to do a little more scraping. My bet is on scraping. First up, just looking at the mounting surfaces on the bottom of the saddle to see if they're at least coplanar. No, but not terribly bad. I expected worse. Looking at that, I'll just need to do a bit of scraping to get those level again. There's obviously a low corner here, but that's not awful. What about the gibs I just made? How flat did they end up? Well, this one hinges in the middle, so it's obviously bent in this direction. And here it hinges at the ends, which once again confirms that it's bent in this direction. And the thin one, which goes at the back, it's also hinging pretty much in the middle there. Although not as bad as the other side. Yeah, not awful, but I will give them a bit of scraping. And the last parts I'll need to check are the 2 machined ramps which the gibs run against, and for that I'll have to blue up my straight edge. Oops. So this is the front gib block. Yeah, it's also slightly concave, bit of a blob of ink there. And the rear one. No, the rear one doesn't look too bad. I guess I should also look at those mating faces. And that's reasonably flat. And that one's concave. Since my Linux guru, who designed the gearbox programming for the MAHO, felt that last week's episode was too boring because there was excessive scraping, I'll make this episode completely scraping free just for you. We've finished the machining, or at least most of the machining on these parts. The only part still to make is the adjustment screw, but I'll leave that to next week when I also fit all these parts, get them working nicely together. Once again, thanks for watching, and if you like what you see, please like, hit a subscribe, recommend it to your friends. I appreciate it.